Hello, my name's Cecil, and today I'm going to walk you through a few examples of one-to-one and inverse functions. In our first two examples, we want to determine if the following tables are one-to-one functions or not, and if not, we want to point out what values make us come to that conclusion. So in order for us to do that, we first need to know, well, what makes a function one-to-one or not. What makes a function one-to-one or not is dependent on the idea that there is no value of x which will give a repeated y. So for example, if we have a normal linear function, if you look at any section of this, any horizontal section or any vertical section, you'll see that there's no line that I can draw where there's 2 points that intersect the line. The horizontal line test can tell us within the region graphed if it is 1 to 1 or not. And if we were to look at tables, we would look for repeating y values. And if it's repeating x values with different y values, obviously it won't be a one-to-one function either because it just won't be a function. If we want to look towards our examples, we have just some tables of random values for some function. We don't know what that function is, but when we plug in these x values on the right, we get these y values on the left. For the first one, we get -2 when we plug in -1, 0 when we plug in 0, 2 when we plug in 1, 1 when we plug in 2, 0.5 when we plug in 3, 0.33 when we plug in 4, and 0.25 when we plug in 5. As we can see, we get no value of x across all of them that is the same, and no f of x or y across all these values that is the same. So that tells us that because there's no repeating values, the table is of a one-to-one. In the next example, again, f of x and x, f of x is just y. We have 0, 0, 1, 1 from the left to the right because typically we have x, y for points. 3, 5, 4, 6, 5, 5, and 6, 7. So if we look carefully, we can see that there's no repeating value for x, so it is indeed a function. However, these two values, 3, 5, and 5, 5, have the same y value. Because of the points 3, 5, and 5, 5, the function isn't 1, 2, 1. For these two examples, we're going to want to determine if the following equations or graphs are one-to-one, and if so, we want to find the inverse function. If they aren't, why? So for the first one, if we do the horizontal line test across at any point above x equals 0, then we're going to see that when we make that line, that we're going to have 2 points that intersect the horizontal line. So that already tells us here that it is not. These points are supposed to be 0, 4, and 4, 4. So all we have to say is, so the function isn't one-to-one because it fails the horizontal line test. If we didn't have the graph, we could also just plug in points such as f of 3 is equal to 3 squared minus 4 times 3 plus 4, which would give us 9 minus 12 plus 4, or that would give us 1. So we'd have the point 3, 1. We could also plug in other values and see if we get the same thing. So f of 1 would be equal to 1 squared minus 4 times 1 plus 4, or it would be equal to 5 minus 4, or 1. So our second point would be 1, 1. So that again shows us that we get the same value. So that also tells us that it's not one-to-one. For a final example, if we draw a horizontal line anywhere along it, we're going to find that it doesn't intersect more than once. That tells us for sure it's a viable option for converting into an inverse function. What we'll have to remember or be careful about is the shape of this line. So, what we're going to want to do, we're going to say just f negative 1 of x because that's the same as the inverse function. So we're going to say f of negative 1 of x is equal to, and we're going to switch the places of x and y. X equals the square root of y plus 4. So we're going to want to solve for y. So if we square both sides, and keep in mind, as we square these, we're going to have to be careful to now put a restriction on the domain. Why? Because if you were to graph the resulting function, and we'll do so in a second, we square both sides, we get x squared is equal to y plus 4. The inverse function is equal to y, which is equal to x squared minus 4. If we graph this function, we're going to get something like this. Well, this is not the same because it has this other side here that doesn't exist on our graph. So we don't want this half. We're going to want the half where it stays. Since we're flipping it along the x equals y, when we take the inverse, when we flip this, we're going to get a shape something like that, roughly. And so we don't want this part. So we're going to say that the function is only true when x is greater than or equal to 0. So that will get rid of this part, so that we'll only have the section that we want here. So I hope that helped, and I will see you in the next one. Hope you have a great day.